All right, welcome back to the deep dive. So, the material you sent over for this one, we're really getting into the engine room of information science, aren't we? Data processing.
We really are. It's that foundational choice, you know?
Huh.
Every single system, every business, they have to decide the moment data comes in, does this go to a person or does it go to a machine?
And that one choice dictates pretty much everything that follows.
Everything, your budget, your staffing, how reliable the whole thing is going to be, it all starts there.
Okay, so let's unpack this. Our mission for this deep dive is to really get into the weeds on the two big methods, manual processing versus automatic processing.
Right. What are the trade-offs? And maybe more importantly, what are the criteria that force your hand one way or the other?
And the sources seem to boil it down to a pretty simple distinction at first. It's human effort versus computer power.
Yeah, that's the top level. But the real decision, the litmus test for which one you must use, it always comes down to two things.
Speed and accuracy.
Speed and accuracy. Everything else is secondary.
Okay, let's start with the one we all kind of know viscerally. Section 1, the human-powered approach, manual processing. I mean, the phrase itself just gives me anxiety. I'm picturing a huge stack of paper on a desk.
It absolutely should. And by definition, that's exactly what it is. Manual processing is, well, it's carried out entirely by people.
No fancy automated tools doing the work.
None. The key thing to get here is that the human isn't just supervising. The human is the processor. They're the engine, the calculator, the quality check, all of it.
And when you make a person the engine, you get predictable problems. The sources are very clear on this. It's slower, a lot slower, and it's much more prone to errors.
Much more. And we always talk about the speed, but the errors. That's the really interesting part.
Why, fundamentally, is a human so much more error-prone than a machine in this context?
It's about consistency. Or lack of consistency. A computer runs a line of code perfectly, the exact same way, 10,000 times in a row. A person gets tired. Their mind wanders. They might, misread a messy number on a form, which is the classic example the sources give. Handwriting data entry.
Oh, that's a perfect example.
Right. Or after 5 hours of typing numbers, they just switch 2 digits. It's not a failure of the person. It's a feature of human biology. We're not built for that kind of repetitive perfection.
So the fatigue factor is like, it's an engineering flaw in the process itself.
Yeah.
You're not criticizing the worker. You're saying the system relies on something humans just aren't good at long term.
Exactly. And just try to visualize that handwriting example. You're sitting there, hundreds of forms, trying to figure out if that's a 1 or a 7, typing it all in, one character at a time.
It's slow, and the chance for an error happens twice. First when the person wrote it down, and second when you try to read it.
Precisely. And this gets into a cost issue that the sources don't spell out, but it's definitely there. With manual, your setup cost is low, right? You just need a desk and a person.
No big software investment.
Correct. But you trade that for incredibly high operational costs. You need staff, training, managers, people to double-check the work, people to fix the errors. That cost scales up with every piece of data you process.
So cheap to start, but gets very expensive to run. And it probably breaks if you suddenly get a huge spike in volume.
It shatters. But we should be fair, it's not completely useless. There are some things it's still good for.
Like what? Where does a human still win?
Judgment. If the data is messy, unstructured, maybe you're trying to figure out the sentiment in customer complaints or interpret a complex legal document, you need a human brain for that nuance. But for structured data, high volume, no. You have to look elsewhere.
Which, of course, brings us to the other end of the spectrum. Let's pivot to Section 2, the digital engine automatic processing.
Yeah, and here the whole equation just flips. Automatic processing is done by computers. The key is it requires, very little human input.
And that's the so what, isn't it? The fact that you take the human bottleneck out of the equation.
That's the whole game. The system is no longer limited by how fast someone can type or how long they can focus. It's just raw computation.
And the performance difference isn't just a little bit faster. It's orders of magnitude. How do they do that? Is it just processing power?
Power is part of it, but it's really the architecture. Automatic systems can do things in parallel. A person does step A, then step B, then step C. A computer can do 1,000 different step A's all at the same time.
And the sources nail the benefits way faster and much, much more accurate.
Because of that consistency we talked about, the machine follows the rules perfectly every single time. It doesn't get distracted. It doesn't get tired.
And the cost structure is the complete inverse of manual then.
The complete inverse. You've got a huge upfront investment, software, hardware, getting it all to work together. But once it's running, the cost per transaction is tiny.
Expensive to build, cheap to run, and built for scale.
Exactly. And you can see why modern systems depend on this. I mean, could you imagine trying to run the stock market or global shipping logistics manually? The system would collapse in an hour.
The sources gave two really great concrete examples of this. The first one is barcode scanning.
A perfect example.
Yeah.
So simple, but so powerful.
Right. A laser reads lines, it instantly queries a database and pulls up the price, the inventory, everything.
It happens in the blink of an eye, and it's almost perfectly accurate. Now think about the alternative. The cashier has to manually type in that 12-digit product code for every single item in your cart.
Oh, the lines would be chaos, pure chaos. The whole retail model would be impossible.
It would. And the second example, this one has even more serious consequences. Payroll systems.
Yeah. You absolutely cannot have errors in payroll.
You can't. And this is where speed and accuracy become critically important. You have thousands of employees, all with different hours, tax rates, deductions, bonuses.
That's so many calculations.
So many. An automatic system just does them instantly and flawlessly. And it documents everything, which you need for audits.
And if you tried that manually,
You would guarantee mistakes. And a mistake in payroll isn't just an inconvenience, it's a legal problem. It's a financial penalty. It's your employees completely losing trust in the company.
the moment the consequence of an error is that high legal disaster, you're basically forced to go with automatic processing. The risk of human error is just too great.
And that leads us right into Section 3, which is really about synthesizing this. It's all about those decisive criteria, speed and accuracy.
It's important to frame this right. The sources aren't saying manual is bad. They're saying it's limited.
Right. A system designer starts by looking at the job to be done.
Exactly. They look at the volume of data and the potential consequences of a mistake.
So if we connect this to the big picture,
Well,
the choice is all about what the job needs.
it really is. If you have, I don't know, 3 forms to log per day, and it doesn't matter if it takes an hour, sure, manual is fine. It's simple. It works. But the second you need to manage an inventory of 10,000 items or process 1 million transactions for the stock market.
It's non-negotiable. You have to use automatic processing. The designer asks, does this need to happen in real time? Or will an error here cost us millions? If the answer is yes,
It has to be automatic.
it has to be. And that shift really defines our modern world. Manual processing is now for niche tasks, low volume, low stakes, or when you need that human judgment for messy, unstructured data.
For everything else, the gap in performance and reliability is just too huge to ignore.
Right. So every time you look at a spreadsheet or a database, what you're really seeing is the result of a choice someone made, maybe years ago, about how to handle volume and how to manage risk.
So what does this all mean for you, the listener? It means that processing data isn't just typing things in. It's about a critical design choice, a choice about engineering and risk.
Yeah, the core lesson is pretty straightforward. You can use people, that's manual. It's slow, error-prone, and expensive to run at scale. Or you can use computers automatic, fast, accurate, and cheap to run at scale.
And the choice between them is always, always driven by how much speed you need and how much accuracy you can't live without.
It seems like a simple choice, but it's a choice that underpins everything from how your favorite app works to the reliability of our national infrastructure.
Absolutely. Okay, so to close this out, let's leave you with a final thought to mull over, one that really builds on the implications here.
Okay, so consider the risk. The inherent risk when a system that absolutely demands the scale and accuracy of automatic processing. Think about something like a national voter registration database.
Or the air traffic control system.
Perfect example, a system coordinating thousands of flights. Now imagine that system is badly designed. Imagine it relies too much on slow, error-prone, manual steps.
So what are those real-world consequences? The failures, the crises, the actual danger to public safety that happens when a system designer gets that choice wrong, when they fundamentally misjudge the need for speed and accuracy.
The difference between manual and automatic isn't just about efficiency, sometimes. It's the difference between a stable society and catastrophic failure.
A heavy thought. We'll leave you to think about that until the next deep dive.